Okay, I'm going to be solving the BaekJoon online judge problem EKO, which is also problem number 2805. So the problem is that lumberjack Mirko needs to chop down M meters of wood, and it's easy for him to do so since he has a nifty new wood cutting machine that can take down forests like wildfire. However, Mirko is only allowed to cut a single row of trees. Mirko's machine works as follows. Mirko sets a height parameter, which is h, and the machine raises a giant saw blade to that cut height and cuts off all the tree parts higher than h, and then Mirko takes the parts that were cut off. So if the tree row contains trees of height, let's say 20, 15, 10, and 17, and Mirko raises the saw blade to 15, since this is more than 15, there are going to be 5 meters chopped off. For this, 0 meters, and for this 2 meters. Since this is less than 15 meters, we don't none of the wood is going to be chopped off. So that's going to be 7 meters chopped off in total. So since Mirko is ecologically minded, he doesn't want to cut off more wood than necessary, so he wants the lowest possible amount of wood that's cut. But Mirko still wants to get at least m meters of wood, and he wants to find the maximum integer height of the saw blade that allows him to do so. Okay, so the input, the first integer is n, which is the number of trees, and we can see here that it's going to be less than 1,000,000. And m is going to be Mirko's required wood amount, and we can see that it can go way up to 2 billion. And the second line of input contains n separated positive integers less than 10 billion, the heights of each tree in meters. So the sum of all heights is greater than or equal to m. Okay, so Mirko will always be able to obtain the required amount of wood, so there's no like outputting -1 if it's not possible. So let's try out the first test case. So we see that there are 4 pieces of wood, four trees, and the heights are 20, 15, 10, 17, and explained above here. If they were cut up at 15 meters, we would have 5 plus 2, which equals 7 meters of wood. And so we see here that Mirko wants 7 meters of wood right now, right? So cutting it off at the height setting of 15 meters would work. Now, but the thing is, there are going to be more trees, and it's going to be more difficult to find how much, what height Mirko needs to cut it off with. So let's see here. Let's test the second test case first. So there are 5 trees. Yeah, here are the 5 trees on the second line. And then Mirko is going to need 20 meters of wood. And apparently the output is 36. You can check that. This is going to be 6, 4, and 10. So 6 plus 4 plus 10 is going to be exactly 20, which is going to be how much wood Mirko wants. So we know that we're going to have to solve this using some kind of like algorithm or brute force, right? We're going to have to try to test what kind of height setting that Mirko can put his machine at. But the problem is there are going to be 1,000,000 trees, right? And then there are going to be, and since there's going to be a possible height of 1 billion, since the maximum height of each tree is 1 billion, that means that if we actually brute force this would take 1,000,000 times 1 billion big O's, like big time. So that would be obviously way too much in the worst case scenario, and we can't solve the problem using that kind of brute force. But we have to remember that we're trying to find the optimal height for Mirko's machine, right? So if Mirko has a machine, he wants to keep trying out the heights and seeing which height works. But a faster way of finding the height would be, let's say, some kind of, we would need to use some kind of binary search, because binary searches can find the optimal height extremely fast. So first, Mirko can try, let's say, height of 10, and if that doesn't work, if it's too low, then he can try a higher number, and if it's too high, he can try a lower number, and so on until he gets the correct number. So I can display this with a Google Doc. Okay, so let me open one up. Okay, so let's just take a look at the first example, okay? There's 4, 7, so there's 4 trees, and I'm going to take away the 4, and he currently wants 7 meters of wood, right? So first, we notice that the maximum amount of wood here is 20, right? So the highest possible value is currently 20, or the height that you want to set the machine at. And the lowest possible height, I guess, let me change this to height as well, is currently 0. Never mind that you wouldn't get any wood from it. It's the lowest possible height you could possibly set the machine at. And we see here that the median, or like the mean of these two heights is 10, because 20 plus 0 divided by 2 is 10. So the middle height you can set it at is 10. So middle height is 10. And what we're doing here is we're seeing that if we set the machine at height 10, then how many of these trees could we possibly cut? So let me actually draw out these trees here. Let's highlight this, green. So this is one tree, and here to 15, so here it's another tree, right? And this is 20, this is 15, and then we're gonna have another one, 10, right? 1, 2, 3, 4, 5, 6, 8, 9, 10, 11. Okay, 2. And then we're going to have one that's 17. So longer than this, right? Oh, and I think 3, 4, 5. So yeah. Okay, there you go. This one, has a length of 20, so height of 20, 15, 10, and 17. So right now the middle height is 10, okay? So we're cutting the trees off over here. Okay, so when he cuts it off at the middle height, and we're going to have to include the squares covered by the blue area. So let's see, so this one, we're going to have to cut off this much, which is going to be 1 through 10, which is 10. We're going to cut off 10 here, 10. And then for this one, we're going to be cutting off 1, 2, 3, 4, 5. It's a little hard to see. 5. And this one's exactly at 10. So we're not cutting any off here. And then this one, we're going to be cutting off, let's see. It's everything up, include here. 1, 2, 3, 4, 5, 6, 7. And we see that if Minko sets the height at 10, he's going to get 10 plus 5 plus 7, which equals 22 meters of wood. So let me put that over here. And that's not going to work out because that's way too much. It's more than the 7 meters of wood that he wants. So what we're going to do is, now that we know that every number between 0 and 10 is not is not a desirable height, we're going to set the lowest possible height to 10, and we're going to set the middle height to the average of 20 and 10, which is 15. And this is the concept of a binary search. So let's see here. When the middle height is 15, that's going to be here. We're going to be cutting off 1, 2, 3, 4, 5, and then 1, 2. So 5 plus 2, which equals 7 meters, right? And we find out that that is exactly the answer. Now we could stop here because we know that 7 is the amount of woods that Minko wants, and that's exactly um and that we don't have to go on from there. This could be one of the answers, cutting it off at height 15. But in the actual program, we're going to keep on going. So since this is a possible solution, we have to set the low to this height again. So we're going to set the low to 15, since 15 also works, and we're going to be setting the middle height to the average, which we can right now say it's 17.5, because while we can't technically cut it off at the height, actually we'll be setting the middle height as 17 because it has to be an integer, right? Yeah, the maximum integer height, so it has to be an integer. So we'll set it as 17 for now, since Java rounds down to 17 anyway. And then when you cut it as 17, which is going to be here, we see that only 3 pieces of wood are cut. So 3 meters of wood. And we see that 3, which is the total, is less than the desired amount, which is 7. So we have to change the highest possible height to 17. And then the middle height would now be 16. If we cut it off as 16 meters, which is here, we're going to get 1, 2, 3, 4, 5 meters of wood. So 4 plus 1 equals 5 meters. And this is still less than the desired amount, so we're going to set the highest possible amount to 16. Middle height, 15. And then here, we see the middle height. We see that the low height is still less than the high height, right? And since the middle height and the lowest possible height are the same, and or it could be that the middle height and the highest possible height are the same. Right now we know that it's 15, but we have to continue the algorithm until let's say that the lowest possible height is greater than the highest possible height. So at this point, actually, the algorithm can be ended, since we already found the optimal height, and the answer is going to be 15. But when we're doing the actual programming, we're going to have to make sure that the new middle height is going to be the lowest possible height plus 1, or the highest possible height minus 1, to ensure that we're not like overcounting and that the entire program is going to end at some point. So I think we can get started with the coding, actually. So import java.io, and also import. So we have to import our classes first. And let's say there are going to be like 1 million trees, right? So we're going to probably need some kind of buffered reader, since it takes in the inputs very fast. Print writer. Actually, we won't need a print writer, since it's only going to be we're going to be printing out to the terminal. And then static string tokenizer for the buffer reader, and static int n, the number of trees, and we also have k let's say, which is his required wood amount, and let's say another array which contains all of the inputs, since we're going to need to store it. So we create our main. We get the input, and then we're first going to initialize our entire program. So static void init. String tokenizer. So st new string tokenizer dot read line. And we're going to throw declarations. Right. So n equals integer dot parse in dot next token. And this is getting the number of trees. And we're going to do the exact same thing for Minko's amount of wood that he wants. And we get the input using the integer array a, which is going to be of length n, since that's the number of trees. Okay, now our array is filled. Now, since we're going to have to use the index when we're doing the binary search, we're going to have to sort. We're going to have to oh wait, no, never mind. I thought we had to sort it, but we don't, since we're going to just be checking each of the trees, and it doesn't matter what the orders of the trees are. And then we're going to do our solving portion, which is probably the more interesting portion. So in the solve, we're going to do the binary search, right? So the lowest possible value is obviously 0, which is the lowest possible height that Minko can set the machine on, and the highest possible height is going to be 10 billion, actually, because we remember that the maximum possible height for each tree is 10 billion. So the maximum height that he can also set the machine at should also be 10 billion. So 10 billion. Actually 1 billion. So the middle number is 0. Let's just set it to 0 for now. And then we're also going to have a number called ans. We're going to make it a static int. Ans equals 0. So while low is less than or equal to high, so until Minko reaches the optimal limit by using the binary search. So while low is less than or equal to high. So when he does find the optimal value, the low and high values are going to switch. So the low is going to become 1 higher than the max optimal value, or the high value is going to become like 1 lower than the optimal value. So low is 0, high is 1,000, 1 billion, and we're going to have to create the middle height, right? Over 2, which is just finding the averages of the two. And then let's create another function called check. So if check mid, and what check is going to do, it's going to count the amount of wood that the machine cuts at that specific height of mid. And if check mid, so if that height is greater than or equal to the optimal height, which is k, then answer equals mid. since that's going to be our new answer, and low is going to be mid plus 1, since it's going to, we know that all numbers between low and mid are not valid. But let's say that the check doesn't work. And this basically means that there's not enough wood that's getting cut. That means that you can't set the machine at a higher height, or else it's just gonna like cut less wood. So height equals mid minus 1 to decrease the amount of possible heights that we have to search. So we just have to create our class now. Our function now for check static boolean check. Let's say int height. Okay. So the number is probably gonna have to be a long, since each height is going to be 1 billion, and they're going to be 1 million trees. So long total equals 0. For int I equals 0, I less than n, I plus plus. So we're going through the input values that we have for the heights of the trees. Total plus equals math.max 0 a of I minus m. And this is h. So what this is saying is, first of all, the amount of wood you're going to cut off is a of I, which is the current height of the tree minus the height that you're cutting using the machine. But the problem is sometimes the height of the tree, let's say that it's 10, can be lower than the height of the machine, which is 15. But if we evaluated this expression, we would get a negative number, which is not what we want. It's not like Mirko is losing wood for not cutting trees at a lower height. So we're going to have to use math.max in order to make sure that negative numbers just turn into a 0. Then return total is greater than equal to k. So that's at least how much wood that Mirko needs. And after all done, we should just be able to print out. Yes. And yeah, that should work. We should probably test it out. Let's see. Submit. Java 11. Sure. Okay, we have to copy and paste it. And we also have to set the class name to main. Let me submit. Okay. You can see that it's running over here. And yeah, we got it correct. So I hope this video helped you solve this problem. And yeah.